Data of every description will pervade our consciousness. Holograms projected beneath our eyelids. Direct retinal stimulation.
Welcome to the DCC Museum.
Hi and welcome back. Today we are in the beautiful Dallas surroundings meeting Dan Staudacher, and he is one of the lead engineers or former lead engineers of the Tandy Optimus DCT-2000. A lot of you don't know that Tandy was a big part of the Philips working together with various partners. We mostly know the Machusa Corporation that worked with Philips, but Tandy was a big part. They developed their own Optimus DCT-2000. Today we're here to talk with Dan about his involvement, and he will show us some interesting things that he kept all these years.
I'm Dan Staudacher. What I did for Tandy and DCC was I was the main project engineer interface with various companies, with Philips and Marantz Stereo in Japan. So I headed up all the interface and communications, as well as doing the software and hardware development for the control PCB that is in the DCC unit for Tandy, the DCT-2000. Yeah, so just coming off of a layoff from a prior company, I went and interviewed with Tandy. They were looking for someone to do software and embedded software development, and they were in the midst of starting this project called DCC, which I had not ever heard of, but sounded really fascinating. And because I was pretty in tune with what they were wanting to use for embedded controllers, very specialized in Motorola especially, it was a perfect fit, and I got hired on, and I think it was in April of 1991. Yeah, I think that the actual overall design was still in the works. So when I first came on, it was more conceptual, and we were looking at what Philips was currently doing, and some of the equipment that they had available to show us how DCC worked and so forth. So we were still kind of developing the look of it. We knew that it needed to fit into the a rack, with a rack mounted system that Tandy had. It needed to have the same kind of styling, the black, the dark screen and so forth. So they wanted it to fit in with the rest of the audio components that would fit in a rack, as an example. So when I first started with Tandy, the first thing was just learning how to control a cassette mechanism, how it actually worked, and understood it, and then of course wrote some initial software, PC based, that through an RS-232 interface control a model mechanism. I guess I should have brought it with me. But anyhow, the initial mechanism, just to learn how to control the cassette deck, how it actually functioned and so forth. And then shortly after that, I guess that was in April when I came on. By December, I was heading to Eindhoven to meet the guys on the Philips team and to actually learn all about the technology and how we were going to interface together, and to figure out who was going to do what, and to decide on the final design that was going to go into the Tandy unit. No, I don't think there was no complete set at that point. We were pretty much still in the concept phase, and the biggest concern at that point was really they were working on the head mechanism. So the heads at that time weren't lasting but probably a few hours at a time. So it was a constant rework trying to get the heads to work with the film that they were trying to develop, so to make it last long enough, especially with the high-speed searching and so forth, and the heat and the resistance created a lot of damage to the head, and so they had to. We were doing a lot of work with that at that time to try to perfect that the head itself, and to be able to prevent the dropouts and so forth that we were running into as a result of the faulty heads after a certain period of time that they were functioning. One of the biggest selling points at the beginning there was the fact that DCC was a transitional a product where you could be compatible back to the analog tapes as well as the digital tapes. And I think that was, for me, I thought that was a great idea, because I had thousands of analog tapes, and to think that I was just going to throw them all away and start over with a brand new digital tape cassette deck, I thought didn't make any sense. And that it did make a lot of sense to be able to have it backwards compatible and to And I think it was kind of neat to be able to say that you could play either one, So you could still play your analog tapes, which were still good. They weren't as high quality, obviously, as digital, but they still sounded good. We didn't even know any better when we were playing them anyhow. We thought they were great until we actually started listening to digital tape. So I think the backwards compatibility was really a key selling part of DCC at that time. Yeah, there was obviously a lot of pressure with the race to get it finished because of the fact that we knew that with every new electronics product you have a certain amount of lifetime to be able to get it released, but number two, just to be able to attract folks who want to take up that technology. So we knew we had a limited amount of time, and so we worked. I mean, we literally were working 7 days a week, 12, 15-hour days. It got to be even a problem with my wife and I, just because of the fact that it was like I was never home. And one of the classics was I needed to go on vacation, and so we decided we were going to go to Florida. And I think this was early 1992. Really needed some time away, and we headed to Florida. And of course, I was getting phone calls from my boss while I was on the trip the way there, asking me questions, asking me this, where was this at, and what was that at. And so my wife got the idea when we got to our destination, which was her grandparents' house. She told her grandmother that we needed to unplug the phone lines in the house because I was obviously going to get more phone calls. And so anyhow, she unplugged all the phones, and we were there for about 3 or 4 days. And I was like, I haven't heard the phone ring at all. Is your phone's not working? Oh no, they're working just fine. And so never knowing that she actually unplugged them all so that I couldn't get any phone calls. And of course, I did find out later that my boss was really mad he couldn't get a hold of me. But we made it through. And but even that, after one of the trips that I spent over in Eindhoven, after like 2 weeks, I come back, and boy, I was exhausted because we worked really hard over there, and then came back. And I want to say I came back like on a Sunday night, probably 7 or 8 o'clock at night, and finally get home. As soon as I get home, sure enough, I get a phone call. And so my boss, David Clark, he's like, Dan, so we need that stuff that you got, from Philips. When can you bring it in? And I'm like, Dave, I just got home, I was like, this is Sunday night, what's the hurry? Oh, we got to have it. We got to have it first thing in the morning. And I'm like, Dave, I'm exhausted. I need to sleep in tomorrow. No, we got to have it at 8 o'clock in the morning. So my wife was so mad that I had to get up early that next day and drive into Fort Worth to give him everything that I brought back from Eindhoven. But it was that kind of thing where it was just constant, constant pressure, until finally, we were able to, finally see that product come out. I don't think at first we didn't know how long it was going to take. We knew we were trying to hit some deadlines like CES as an example, and of course, obviously, the big thing was getting it for Christmas. We didn't know if it would be 92 or whatever, but I think we were probably initially looking at 92. But then ultimately ended up being 93 before we could finally get it released and get all the bugs out of it, and of course for Philips to be able to have a mechanism that was going to last, and they knew was actually a viable product at that point. So, but yeah, so it was a long process, but there was so much that was new, and of course the inner workings between Tandy, releasing the first unit for the U.S., Philips, all of Europe, and then Marantz in Japan. Coordinating all that too was also a big deal because they didn't want one of us to get out before the other, and so everybody had to be put out at the same time. So there was some coordination that went on and ended up ultimately making it Christmas '93. We had worked so hard, and we wanted it to be perfect when it got put out. When it came close time for Christmas time, we had pressure all the way to the CEO that it had to be out. I mean, we had magazines, we had articles, we had the Radio Shack catalog, everything was ready to go. And so we had no choice, that had to be done. And we found out right before it was going to ship that we had a problem. And we knew that we didn't know exactly what the solution was, but we were having some problems with some failures in some of the stores as they were testing out the units. And so, but they were ready to ship everything. And I told Dave, I says, no, we really should not ship. We need to fix these before they get sent out. And he's like, no, what I've decided what we're going to do is we're going to not tell anybody. We're going to ship out all the units just like everything is normal. But I'm going to hire a bunch of extra technicians. I want to say there was probably 25 or 30 technicians that he hired temporarily to go out across the country all at one time, literally fixing units in the stores after we come up with the solution for the repair. And I thought that was just the craziest idea I'd ever heard of. And I said, that is not going to work. People are going to find out, and at some point this is going to blow up. No, we're going to make it work. We're going to make it work. And because his reputation was on the line, he felt. So we went ahead and did it. And I knew, sure enough, the word got out that there were some problems. The stores were afraid to sell. They weren't sure if they should do it or not. And they were out there, trying to repair these units on the fly. And then, of course, Christmas comes and goes. The sales were way down, and there were nothing like we had, I had hoped for. It was just the unit was too expensive. People weren't aware of the unit. There wasn't enough advertising and so forth for it, and it ended up, being a big flop after it was all said and done. And ultimately, I knew that there was not much time left before, we were going to get the word that our team was going to probably be fired as well. So I quickly was trying to decide what my next project was going to be, and whether I was going to be at Tandy or another division, or if I was going to leave the company altogether. And ultimately, I decided to stay with the company, but went to another group to work on DSP technology. Because the number of units sold over Christmas, they figured was probably going to be 70% of their sales for the first year anyhow. And it was so low that they figured this is not going to work. And they decided to pull the plug really that quick. And within a few months after the initial release, heads started flying, and it was all over with. It was an amazing letdown after all that work. Yeah, so as we saw in the catalogs, in 1995, they were still trying to sell the units the initial 50,000 units that we had built. They were still trying to sell them, and I think I bought one of them myself. So at least I helped them out a little bit. Now, as to whether, I don't know how many was ever sold. It would be interesting to know how many were actually sold out there. But I know just the last time I actually looked for some units, I think it was probably about 5 or 6 years ago, and I think I found one or two out on eBay. But there sure is not very many out there. I'm not sure what happened with them ultimately. I think they purchased enough hardware to build 50,000. I'm not sure that they actually ever really did it. So that was the initial plan, and it may have been maybe more like 5,000 that actually was built, ultimately. One of the things about Tandy was the fact that they were really pressing for us to have patents, ultimately to keep the technology and to be able to play off the technology in the future. And so it was always important and really drilled into us as engineers that we always kept design books. And those design books, we had to detail everything that we did, kept track of time frames and things we were working on at the time, so that we could ultimately take that information and put it towards patentable ideas and things as we went along. And I think it was a very unique thing that Tandy had compared to other engineering companies that I worked for. And so this happens to be one of my design books. As I went through it, it was kind of neat to be able to go back and reminisce a little bit about what the process was. And so as I started looking through, and of course I found some of the printouts of the software for the microcontroller and the main control board within our DCC-2000. That was a Motorola HC05 based microcontroller. And as I was looking through here, not only finding the software, but some of the iterations of the design as we were developing the unit. Of course, we had multiple versions of the design itself, but just going back and looking at all the details of the design, and the one unique thing, of course, with the Tandy unit is the fact that we customized it, whereas Philips and Marantz in Japan, they all kept with one design, where we decided to go with a unique design with the DCT-2000, using our own main board as well as the control board and so forth, and just created interfaces to the main circuitry for that Philips had developed. And so anyhow, as going through here, looking at some of the memos and so forth that we had, this was one here, of course, from my manager, Dave Klauken, back in October 1992. This was approaching the time frame we were reaching the end of the phase, but even the display itself, we had uniquely designed our own display and came up with all the different patterns and so forth that we would need, and literally did our own display module, control module, and everything like that. Let's see here as we go through. One of the first things that I had to do when I first came on board was just developing how the actual signals would come from Philips in order to control the unit, obviously, and to control the tape mechanism and so forth. I had to know exactly how the signals, what they look like, and to be able to read them. And so we had to plot them out. But as I first went through the beginning of it here, this was in the very beginning. One of the first things that I had, and I'll show you later, was a little cassette mechanism that we had received from Philips that had a RS-232 interface. And so this was the original first phase where I had to develop a control board in order to run that little interface and to be able to learn how to control the mechanism. This was back from April 1991, and we called it the AR350 interface that we first developed, so I could start writing the software and actually control the unit. And of course, I had to reverse engineer a lot of it because we didn't really have anything written down. So I just took the unit at face value from Philips and just started, probing into it and reading the signals off of it and determining how I was going to actually sync up with it, and also to be able to read the tape and control the tape mechanism, as well as sending the data from Philips up to the control panel to display it on the display. This was the actual RS-232 interface that we first used. As we move along here, this is April, here comes May. We started looking into some of the issues that we thought about, that we were finding as we were trying to use the initial first mechanism. This here was the DDSP control interface to the DDSP board from Philips. Then I started looking at how, if we had all the different modes, right? They had stop mode, play mode, fast forward, rewind. With each mode, you had different things to deal with, and so we had to think through. And I did an actual block diagram to actually determine how every functionality was gonna work together, whether you were in play or stop, or if somebody stopped something in the middle or searching for the next song, how are we gonna implement that? So all these different notes here, taking us through the first demo of the DCC unit. Here we're actually reading off characters to be able to read the data off the tapes. So we had a couple pre-recorded tapes that had the data on it, so that we could start learning how to interface with it. So the actual tape controller, the tape counter and so forth was a big deal, because we actually had to count in order to determine where we were on a tape, or to determine length of the tape. We would measure the tape counter, use the tape counter to send up to the display as an example, because the old analog cassette tapes and cassette decks had merely just a tape counter. They didn't have any real-time display. They really just had a tape count. And one of the things that I remember now Frank had developed was a way to convert from tape counter to an actual real-time conversion, so that he could display, 1 minute 25 seconds into the tape. And so, but as time went on, you started at the beginning of the tape, you had a full reel to go through. So the tape would not go as fast, but the closer you reached to the end of the tape, the faster the mechanism would move, because there was less tape to pull. So we had to compensate in order to create real-time display. We had to compensate for that based on how far we were down the tape. So there was a lot of calculations that we had to do in order to simulate that. That's basically what we were doing, was simulating real-time from a tape counter, which I thought was kind of cool. This was actually running some, plotting out some variances between different tapes, whether it was a 45, 60-minute or a C90 tape, to compare the time lapse from beginning of the tape to the end of the tape. This was back in June of '91. Let's see as we go through it. Oh, so this was interesting here, part 2, where so we went out and bought all the DAT units that we could find. This was a Sony 75ES, then we had a Victor, an Excelia, a Denon D2R2000, and a Sony unit here. So I went through each one and jotted down all the functionality of it, how they worked, and what they would do upon pushing one button versus another, to try to compare them in order to pick the best functionality from each of the DAT units and incorporate that into the DC-2000. I actually still have this Denon unit because it was the prettiest of the units, the DAT units that we had. I'll show you that a little bit later. Got that up in the media room. So kind of breezing through here. So these are just my notes on each of the units and what the differences were and how they function differently from one another. Then of course, let's see. This was going along here. Majority of these design notes is all about the interfacing to the cassette mechanism and being able to created some equations to determine the optocycle versus the tape speed and so forth. So there was quite a bit of math calculations in order to incorporate that into the software. Let's see here. Speed control. This was the speed control circuit that we used to interface to the mechanism. Then we started looking at also too the actual signals coming off the tape. This was from the Marantz. This is the automatic search music system from Marantz. The envelopes that would be generated through the eye pattern on the mechanism, we would use that to basically filter the envelope into pulses, and then use those pulses to measure those pulses to determine whether we were in the middle of a song, or if we were hitting the end of between songs, or ultimately reaching either the beginning or the end of a tape. We had a lot of communications going back and forth, and what I would generally do is, and I've got some examples in here, where I would just jot down all the different issues that we would run into, and then we would have a meeting with Philips in particular, and we'd run through some of the issues or questions that we would have. So we had a lot of phone conference calls, and also faxing information back and forth and questions back and forth in order to work through the problems that we were running into. And then ultimately, I had to go over to Eindhoven, I think probably about 4 times altogether through the process, because there was quite a few times where I just had to be there in person to really see what was going on, and also to be able to take back and forth hardware and pick up hardware. It was much easier to do it in person than it was just to try to ship it over, because a lot of stuff was pretty critical. In fact, I made a special suitcase for my DCC that I would carry with me, because I'd bring the unit that I was working on, and I'd bring it over there to Philips, and we'd sit down and work through some of the issues, because our boards were quite different than the Philips DCC 900, and so we had some unique problems that we had to deal with that they didn't actually have, and so that required actually bringing the equipment back and forth from time to time. Yeah, so we were talking about the very first time I went over to Eindhoven. One of the first things we started talking about was the head technology and how they went about the design of having the multiple digital tracks, both for side A and side B of digital tapes, as well as having your 2 analog tracks, A and B, as well, all on one head substrate. And we talked about the fact that Seagate was initially going to be the ones, because they were so experienced, with hard drives, that they would probably be best suited to actually develop the head. But it created a huge backlog, and ultimately Philips had to bring it inside in order to make it happen, because in the beginning, the technology worked, but the film on the head itself was so quickly deteriorating that by the time you get to using the unit, the head wasn't any good anymore. And so that became the major obstacle of really getting the units actually built and shipped, was all about the head. That was the whole key to be able to have a successful product, was solving the problem of the film, being able to protect that head mechanism so that in fast searches and so forth, the heat wouldn't destroy it. And but ultimately, I had forgotten about the fact until you mentioned it, that Seagate was the original ones that we were going to work with on those initial heads. So as we're looking right here, this is my basement upstairs, because we don't have basements in Texas, so I have got my little memorabilia room here, of which I kind of brought together some of the components and so forth. I've got 2 different DCC units here, complete DCT-2000 Optimus units, along with various. I've got about 5 or 6 different complete mechanisms still here. In fact, this one here, I was going through them trying to figure out which one was the best complete functional. I've got them in different stages at this point. Over time, there's been some deterioration, where I've got this unit here where it works analog but not digital. This one's not recording. This one over here has got good playback but no recording. So we're trying to get these things back and functioning again. I've got together here a lot of some of the original Philips DCC tapes. This is a 90-minute tape, still in cellophane. And I've got the whole box here of the Tandy Super Tape brands. These were also 90 minutes DCC tapes. Spent many hours using these various tapes, because the tape was also a hard issue of getting a good enough quality tape. Was a big issue for a long time. One of the things as we were looking through here, besides having all kinds of duplicate boards and so forth, I probably have the largest collection of what's left from here in the United States of the DCC stuff. But as we were looking through, this was some of the notebooks that I had, where I've got all the data sheets for the specific Philips DCC chipsets and so forth. So all the descriptions and everything that you would need to have, which these were critical in the beginning because this was the only way that we could develop our side of it was having these data sheets, which evidently are pretty rare, hard to find. But I've got a copy of them all here, so kind of neat there. This was also looking at some of the Radio Shack magazines. In fact, this was the 95, yeah, 93, 1995. This was the 1995 one here, where I've got the DCT-2000 that was still being sold. Let's see if I can find it now. What page was that on? Oh, here it is. Yeah, so we got the DCT-2000 and the remote control. A new deck is the perfect addition to any home. A new sound of music is on digital compact cassette. So anyhow, as you can see, it was in the same line as all the other audio equipment that Radio Shack was selling at the time. So this was the very first piece of hardware that brought back from Philips, and this was the initial unit that I used to interface with through the RS-232 port to be able to control the mechanism, to be able to not only make it play, fast forward, rewind, eject the tape, all the different various functions that the cassette mechanism had, but also since we had a read-write board here, I could actually play digital tapes and read off the data so that we could develop the software to ultimately function in the real unit later on. So this was a critical piece in the very beginning, probably one of a kind as well. So I've got additional hardware here. This is here is one of the front panel displays that was also a Tandy design. As you can see here, complete hardware design for the front panel, and all the various components that went along with it. I've been kind of a collector of lots of things over the years, especially being in the heart of the design of the DCC project. I just wanted, it was such a big part of my life at the time. I wanted to be able to keep some memorabilia, and so for the most part, they were going to go to waste anyhow. So I collected them, and of course a lot of times I was doing work at home as well. So a lot of the components and stuff ended up staying at home, and ultimately when we were reaching the end of the project, I tried to keep as much of the stuff as I could, because I wanted to be able to to play DCC and to have functioning units as long as I possibly could, and show my kids that when they grew up, so I could show them stuff that we did way back then. So, and I'm glad now that fortunately that I did save a lot of this stuff, never knowing that it was actually going to be something where it could be in a museum, or people actually appreciating the technology that we worked so hard on for so many years. It was a little over a year ago, maybe almost 2 years ago, the first time I was contacted. And the funny thing is that so Facebook is definitely not one of my favorite things to do. I've used Facebook, pretty much to put some pictures of family and stuff when we go on trips and whatever, and it's a way to be able to share, video and pictures with some family. But I never really spend much time on it. Like my wife, actually, she's always on there all the time, sending messages out, but I don't really like to do that very much. I was like, why does people need to know all my what's going on in my life? So I just don't understand that, why people want to share so much. But I got on there one day and was checking messages, and sure enough, I get this message that had been there for, 6 months or something, from Ralph, coming from California. And I'm thinking, what is this? They're asking me about DCC, and so there was a reference to the website and some videos of folks from Philips and so forth that were being interviewed. And I thought, wow, is this for real? I couldn't believe it. And ended up sending a message back to Ralph and sending him my phone number and email so that we could talk like normal human beings, over a telephone instead of through Facebook messaging or something. And so we got to talking, and I was amazed. I never even knew that the DCC technology had ever taken off. I thought that once it was over in '93, that was it. And come to find out that Philips had developed multiple units for the next couple of years, as well as in Japan as well. So I was delighted to find out that it was actually people who actually cared about it, and that there was actually something I could incorporate into by having saved all this equipment and technology here that actually could go into the museum itself, and to be able to show people exactly how this all happened, and to be able to have a legacy left on for people to see in the future, because I think really the technology itself is something that there's really no competition for it, and to be able to have an opportunity for people to learn more about it, I think there's a lot of people that would enjoy it. So.
Okay, thank you. That's a perfect ending. Thank you.